integrating factor of the given differential equation, so that which will make exact, the given differential equation exact. So it is in the form of m dx plus n dy, where m is nothing but xy cube plus y, and n is nothing but 2 times of x square y square plus x plus y power 4. Now let us check dou m by dou x, dou m by dou y, and let us find dou m by dou y and dou n by dou x. Now this dou m by dou y is nothing but 3xy square plus 1. Similarly, dou n by dou x is nothing but 2 times of 2xy plus 1. Now let us check dou n by dou x minus dou m by dou y, which is nothing but 4xy plus 2 minus 3xy square minus 1. Sorry, this will be xy square, so xy square. So entirely it will be xy square plus 1. Now just look into the given expression, xy cube plus y. This can be written as xy square plus 1 times of y. So if I divide this expression by m, that is 1 by m times of dou n by dou x minus dou m by dou y, that is nothing but xy square plus 1 by y times of xy square plus 1, which is nothing but function of y alone. So integrating factor is nothing but e power integral 1 by y dy, which is e power log y, and which is equals to y. So the required answer is option D.
Function of the system is given as z of s, that is, it is given as a ratio of two polynomials. The ratio of numerator polynomial and degree of, that is, the degree of numerator and denominator polynomials are differ by 1. Hence, the driving point impedance, which is given in the question, is nothing but an LC impedance, LC function. So again, if we draw a pole 0 plot, this is pole 0, that is s square is plus or minus this again 0 0 0 0. So the poles and zeros are going to be interlaced alternately on j omega axis, that is, it is an LC impedance function, that is option B is correct.
Three-phase three-wire balance system was measured by 2 wattmeter method. The reading of one of the wattmeter was found to be double that of other. So I can say that W2 is equal to 2 types of W1. Okay. What is the power factor of the system? Power factor cos phi for the 2 wattmeter method is given as cos of tan inverse times of root 3 into W1 minus W2 divided by W1 plus W2. So from this is cos of tan inverse into root 3 times of one of the wattmeter reading is double to that of other. So I can write this one as 1 by 3. Okay. Or you can write this one as W1 is equal to 2 times of W1. Anything you can take it. Okay. Now plus sign suggests here lagging power factor, minus sign suggests leading power factor. In options he has not given anything about lagging or leading, so no need to worry about those. Okay. So cos of tan inverse 1 by root 3 is 30 degrees. So cos 30, answer is 0.866 is the correct one. Option B. R was measured using VI method. Okay, voltmeter ammeter method, with V read as 10.14 volts, I read as 5.07 milliamps. Which one of the following express the value of resistance? What is the value of resistance? R is equal to V by I. So this is 10.14 by 5.07, which is equal to 2.00 kilo ohms. Okay, since it is 5.07 milliamps. See here, he has always expressed this voltage and current ratings in up to 2 decimal digits. So we have to express resistance in terms of 2 decimal digits. So option B is the correct answer. It is operating at leading power factor, then okay, generator means, suppose if you have a unity power factor line, this one, this is over excited zone, whereas this one is under excited zone. Okay, when it is under excited, okay, generator will have leading power factor in excited zone, whereas lagging power factor in overexcited zone. Okay, this is for generator. Okay, motor characteristics are quite reverse. Under excited zone motor will have lagging reacting power, whereas overexcited they have leading reactive power. Now this generator is operating at leading power factor, that means it will fall into under excited zone. So option A and option C can be eliminated. Okay, now what about the sign of reactive power? Okay, since it is generator, generator will always deliver. Okay, motors will always consume. So option B is the correct answer, under excited and deliver reactive power. Following is polar plot with open loop transfer function. G of j omega is equal to k by 1 plus j omega t1 into 1 plus j omega t1. Okay, now polar plot is drawn. Okay, now what is magnitude for this one? At omega equal to 0, he has given transfer function as k by 1 plus j omega t1 into 1 plus j omega t2. Now at omega equal to 0, magnitude is equal to k. Okay, and angle for this one is given as phi is equal to minus tan inverse of 2 times of omega t1. At omega equal to 0, tan inverse of 0 is equal to 0. So this is k at an angle 0. Now what is its magnitude and angle at omega equal to infinity? At omega equal to infinity, it is having magnitude of 0 and angle of minus 80 degrees. Now from these options directly we can eliminate option A and option D, because this is touching at 270 degrees. Okay, what is the phase angle we have at omega equal to infinity? That is 180 degrees. So option C and option B are touching at 180 degrees. Okay, now at omega equal to 0, this is having a fixed magnitude value which is equal to k. Now if you increase omega value from 0 to infinity, it will move towards minus 180 degrees. Okay, this option is intersecting, this option C is intersecting y-axis at 2 points. Okay, this happens only when you have negative signs in the denominator. So option C also can be eliminated. Correct option is option B.
Transform of a given Gaussian pulse e power minus et square a greater than 0. So for the transform, that is f of omega is equals to f of t e power minus j omega t dt. So if we substitute this one, it is square e power minus j omega t dt, we will get f of omega as root pi by a e power minus omega square by 4a, that is option A is correct. Mode input voltage for the op-amp network shown below is, suppose I am assuming this node potential is Vi1, this node potential is Vi2, that is Vi1 minus Vi2 is nothing but Vd. So these two node potentials are same. So here if we apply KCL at node VA, that is VA minus Vi2 divided by R2, VA minus V0 by R1 is equals to 0. This is equation 1, this is equation 2. Similarly, VA minus Vi1 divided by R2 is VA by R1 is equals to 0. This is equation 3. So hence V's common mode voltage is nothing but Vi1 plus Vi2 by 2. So from the given expression, Vi1 is Vd by 2, 1 plus R1 by R2. Vi2 is minus Vd by 2 plus Vd by 2 R1 by R2. So if we add these two terms, we are going to get 1 by 2 Vd by 2 R1 divided by R2, that is Vd R1 R2 1 by 2, that is half of the output voltage, that is option D is correct.